All right. So today's topic, I think, is a very popular topic, and we're very excited to bring it to you. This topic today is about computer vision and how to deploy at an enterprise level. We get a lot of questions about computer vision. It's definitely one of the more popular topics at Fourth
Yeah.
Brain. Just quickly, a little bit of background or housekeeping before we get started with the actual presentation. First and foremost, Fourth Brain. Who are we? What do we do? So to launch a career in ML, you need more than just technical knowledge. You need real world practical skills that companies are hiring for today. So at Fourth Brain, we give you these skills by taking learning to the next level. We're very fortunate that we're backed by Andrew Ng's AI Fund, and we're very pleased that you'll get the skills that you need to succeed. We offer two programs right now. We offer what's called an ML Ops program, and we also offer a machine learning engineering program. Both programs are designed to teach you business, technical, and communication skills that are really needed today in the workforce. So I'm very, very excited to bring to you an amazing guest speaker that we have. I've known him for quite a while through networking, through the AI community. Our guest speaker is Akshay Tashnawal. And just quickly, some background on Akshay before he gets started, which I assure you will be very soon. Akshay completed his master's in artificial intelligence and multimedia data management. He's been working for over 5 years in the AI and analytics domain. Currently, he's at a company called Mindtree Limited. He's also an AI creator at Topcoder, and he's also an associate editor at the AI Time Journal. So he's a very busy person. He's very passionate about AI and ML. And really what I think is special about Akshay is that he's associated with a lot of AI communities that really give back to the larger data AI ecosystem. He's part of AI for Good, also the Good AI, and other communities that emphasize ethical and sustainable AI development, really noble causes. And I think that's great. And that's why we love bringing people like Akshay to speak to our audience. They're people that really care a lot. So Akshay, I'll turn it over to you. The presentation today, everyone, we have the schedule for about an hour. So the first part will be Akshay presenting. He will take some of your questions at various points. You can feel free to just post them into the text chat. I'll be fielding the questions and feeding them to him at different points throughout his presentation. And then at the end, he'll open it up just for a live Q&A session. So without further ado, Akshay, why don't you take it away?
Sure. Thank you so much, Matt, for this wonderful introduction. I think, you said a lot of good words about me. I'm really it's a pleasure and my honor to be, part of Fourth Brain and be a guest over here. So thank you so much, Matt, for that wonderful introduction. Hello to everyone from, all the different parts of the country. Basically, I'm from India. So, that's about me, where I come from. And it's great to see so many people coming from all over the world. So as Matt introduced that today's topic would be, focused to what computer vision is all about and how enterprises are actually, investing in CV and vision analytics and computer vision capabilities, why it is need of the hour and what kind of future it has, 10 years, 15 years down the line. And if you are planning to, work in the CV domain, why it's a good idea to do that. And the kind of walkthrough that we'll be doing will be understanding what AI is all about and what are the different types of artificial intelligence, just to make sure that everyone is on the same page. Okay, it shouldn't be that we are jumping straight into CV and many people are not aware of what AI is. So we'll first understand what AI is all about, the different types, then jumping into CV, the basics of computer vision, enterprise level, future growth, market prospects. And I'll try to show you all a demo, but I'm not sure if the training of that classifier will complete or not. If not, I'll be giving you all an entire walkthrough of how the code structure looks like for a computer vision use case. And in between, I would love to take up your questions Matt suggested. Y'all can post your questions there in the panel, and he'll be putting those to me, and I'll be happy to answer them. Okay, so I'll start sharing my screen, and we'll quickly understand how it goes. Okay. Okay, great. So this is our agenda. Okay, this is what we are going to talk about, what we are going to know. Okay, it's a very interesting use case. As Matt said, this is a use case, this is an area of artificial intelligence, which has a lot of scope, 10 years, 15 years down the line, and how it is actually used at enterprise level, so we'll be understanding those things. So this is going to be the kind of roadmap that we'll be following. What is, the overview of AI? Why is it growing? CV, the need for computer vision, enterprise level impact, future growth prospects. What is the future of vision? Okay, when we talk about, and some concluding statements lastly. And I'll be giving you all a walkthrough in the form of a Jupyter notebook, okay, as well. So I think I will have to skip the slide because Matt gave a really wonderful introduction about me. So, currently I'm working as a technical lead at Mindtree and an AI creator at Topcoder, as well as an associate editor at the AI Time Journal. So I love to read, write about artificial intelligence. Okay, so I'll quickly skip that and I'll jump into our main area of AI and computer vision. So what we understand by artificial intelligence is any area, it's an area of technology that automates, mimics, and learns from human to provide intelligent capabilities to computers, machines, and systems. Okay. Now, when we talk about AI, it is not just restricted to your mobile device, to your smartphone, to your laptop, to your desktop. It is much more than that. Okay. Robotic systems, machineries, everything can be powered with the help of artificial intelligence. It is that powerful, and it has many forms. Okay. It comes in different types. So the basic, which is, very highly in demand, that's machine learning, which is used for predictive analytics, classification, and clustering. Then we've got something called as deep learning. So we'll understand why deep learning is actually used for computer vision. Okay, many people are confused that why can't we use machine learning for, vision capabilities and NLP and all these kind of things. So we'll understand that. We'll talk about neural networks, or very basics. We won't go in depth in terms of neural networks. And obviously, the talk of our topic, which is computer vision, will be jumping deep dive into that. And just to summarize it in a single statement, AI is anything where a computer and system, it takes decision and it helps solve a problem similar to we human do. Okay, so how our brain functions, we look something, we do something, we see something, and accordingly we process some sort of information in our brain, and accordingly we take some sort of action. The entire idea of artificial intelligence is on a similar scale. Okay, so the machines will perceive the inputs from the user, will understand, will interpret what it actually means, and accordingly process that and give you the results or actionable insights and outcomes. Okay, moving forward, when we talk about AI, we've got three major areas. Okay, three major types. Okay, so we've got narrow AI, general AI, and super AI. Now, what does it mean? Okay, when we talk about narrow AI is restricted to do a single task. Okay, now let's take an example of computer vision. Okay, now say for example, we have created a vision system which recognizes face. Okay, so we've created a face recognition system. Now, this is a part of narrow AI because it is doing only a single task, which is to recognize the face. That's it and nothing else. And that is why it belongs to the type of narrow AI. That means it is only performing a single task, a very specific task. Okay. When we talk about general AI is more generic in nature. Okay, so it is as good as a human performing certain task, multiple tasks at a single instance. Okay. One of the best examples for general AI is a humanoid. Okay. For those who are not sure about what a humanoid is, so by the name you can guess it's human plus robots, and that's how a humanoid is created. So a humanoid is actually capable of doing multiple tasks, right from picking up things, emotions, expressions, looking around, taking some sort of actions. So it's not restricted to do a single task. Okay, it can do multiple things. It can do generic things, and that's why it belongs to the general AI category. Okay. Lastly, we've got something called as super AI. Now, as the name suggests, it's super powerful. It is that powerful where it goes above a human mind. Okay, which is quite dangerous to know. But super AI is actually in the research stage right now. Today, we do not have such kind of systems where any system is overpowering we humans. Okay, so that's under research, under development, but let's see how things go forward in the world of artificial intelligence. So that's what we understand when we, talk about AI. So these are the three types that you should know, which is narrative AI, general AI, and super AI. Now, moving forward, the main question is, why is AI growing? You see, today, every technical person, every non-technical person as well, they want to build their career in the world of artificial intelligence. What is the reason behind that? Now, the main reason is data, correct? We've got ample amount of data, right? So right now, when I'm talking and you're listening, right? So we are doing two things primarily. I am the one who is creating data, and you are the one who is consuming the data, right? So there is data generation, there is data consumption, and everywhere where we go, be it offline or online, you're interacting with data. Now, to handle this amount of huge data and exponentially rising information, we need something concrete, right? So we need a technology that actually helps us understand and make some sense out of this huge amount of data. Okay. And one of the more, core areas why organizations are using AI, it is to actually provide better user experience. Okay. Now, today, when you're watching a web series or watching a movie on Netflix, okay, and tomorrow you get a recommendation which you want to see, obviously, that's what the motive of Netflix is all about, right? They want you to, use their app day in and day out. And that's why they make use of artificial intelligence to make sure they provide that information to the user that they are actually looking for, and nothing irrelevant. Okay, so that's how AI is used by organizations all over the world. Now, one of the very good other usages that it saves a lot monotonous human jobs, where so data entry jobs are obsolete now. You don't need a data entry person to actually type in some information, put it in a form, and submit it and check it. It has just got over, it's been obsolete now. So there are no data entry jobs available in the world. The reason is because AI has taken over it. Robots have taken over it. So they understand that what you want to do, and accordingly they perform some automated actions. Okay. And this is basically an ecosystem. Okay. Artificial intelligence in a nutshell, it's an ecosystem where your input is the data. Okay. And you're going to process that. You're going to build a model on top of it. A model is nothing but a mathematical algorithm, okay, which gives you some sort of insights. And lastly, what happens, it provides some sort of valuable insights and outcomes which can help any person or business take better decisions. Okay, so when you get some sort of recommendation from an e-commerce website, from a OTT platform, what you do is you take some decisions, right? So when you are recommended a movie, you decide to either watch it or don't watch it, correct? So there's a decision factor involved when you get an outcome out of an AI system. So that's the idea. So a three-step process to create an AI system in a very brief manner. You have the data as an input, you have the model, which is nothing but a mathematical algorithm, and third, you have got some valuable insights and outcomes, which helps you take better decisions. That's what AI is, and that's the reason we need it. Now, talking about a main topic for the day, which is computer vision. Now, when we talk about computer vision, it's self-explanatory, right? Vision is nothing but what we perceive, what we see, and anything that has some sort of multimedia component involved, like images and videos. So this area of tech, it falls under the umbrella of artificial intelligence. Okay, so computer vision is not obviously you can use it with in isolation, but the bigger picture, if you see, it falls under artificial intelligence that deals with multimedia data, namely images and videos. Now, a lot of people previously used to talk about machine learning. Today, they talk about computer vision and natural language processing. So when machine learning was very famous, in demand, it was used to handle tabular data, okay, your textual information, which were tables, Excel, CSVs, JSON objects, big data, and so on and so forth. And computer vision, it deals with more unstructured and complex information, complex data, which is in the form of images and videos. Okay, now we'll just understand the structure of the image in our next slide. So you'll understand that why images are complex, okay, and why videos are even more complex as compared to an image. And obviously, computer vision plays a very important role in applications like face recognition, object detection, object classification, and more. Today, I'm sure many of you, in fact, most of us are using smartphones. Okay. And in our smartphones, we have those features of face recognition, identifying whether if you're scanning your, scanning from your phone camera on some certain object, it automatically tells you that, okay, this might be the object that you're looking for. So those all applications that you run in your smartphone, they are directly or indirectly linked with computer vision. Okay. Now, let's talk about some sort of fundamentals. Okay. Before we talk about some enterprise level stuff and some real-time use cases, let's talk about the fundamentals and understand what CV is and how it actually helps. Okay. Now, understand the very first important thing when we talk about vision, it is either an image or video. Okay, so whatever you have those components, which is very unstructured, very complex data. Now, why it is complex? Because images is nothing but a collection of pixels. Okay, how an image is created, have you ever thought about? So whenever you have an image in front of you, it is nothing but collection of pixels. Okay, so you might have you must have heard about that term. When you buy a smartphone, you've got something called as 12 MP, which is megapixels. Okay, I'm sure you must have heard about that term called as pixels. So pixel is nothing but the smallest measurable unit of an image. Okay, that's the smallest unit, and when you collect all the pixels and put it in a matrix, you get an image. That's the idea. Okay, now the value of the pixel lies between 0 to 255. Whatever images we see, those images are RGB images, okay, which are red, green, and blue. There's something called as BGR images, which is blue, green, red, the reverse of RGB. There's something called as CMYK images as well, which is more, majorly used for illustrations, vectors, and drawings and printing and those kind of things. But our primary focus is RGB images. Okay. So RGB images, the values lies between 0 to 255. 0 stands for black color and 255 stands for white color. Okay. Anything in between that, okay, you get multiple color combinations. Okay, so say for example, you have the image as 255, 255, and 255. Okay, that means your red component is highest, your green is highest, and your blue is highest. So it gives you a white color. Okay, if your red is 0, your green is 0, and your blue is 0, it has the lowest value, and that's why the color denotes the black color. Okay, and that's how it follows. Okay, so if it's red 255 and green is 0 and blue is 0, that means the color that you have, that is a red color, and so on and so forth. Now, what do you see over here is nothing but an image. Okay. Now this image, what you see on the left hand side, is interpreted by the system in a form of matrix. And this matrix consists of nothing but pixel values. Okay. So what do you see over here? 255, 0, 100, 150, 140, 220, and so on and so forth. This 4 by 4 matrix is nothing but a collection of pixels. Okay. So this is one pixel. This is one pixel. This is one pixel. And this is how, when you collect all of them together, you will get nothing but a image. And that's how we understand images. Okay. It becomes easier for us, but not for our computer systems, not for machines, not for our mobile devices, because they work on binary, they work on numbers, they work on vectors. So everything, whatever you pass in, needs to be converted into some sort of numbers that are understood by the systems. And thus, our images are converted into a matrix of pixels. Okay, that's how it works. Any questions? I'll take a pause over here. So any questions by anyone? If there are, we can take it forward.
Yeah, no, great job so far. Really good stuff. So let me run through a couple of them quickly.
Sure.
So it looks like Dr. Kemalar Selvi, he's an AI researcher and university professor from India.
Okay.
He said, could you suggest the recent research topic in AI? And also, can you shed some light for people looking for a job change entirely into R&D organization?
Okay. Thank you so much for that question. That's a really interesting question. Now, some of the major research areas that's going in and around artificial intelligence is one into the area of natural language processing, and the other is into the area of auto ML and computer vision, where how you actually provide better results by understanding images. And there are multiple developments by organizations all over the world, namely Google, Microsoft, Facebook. They are constantly developing some sort of amazing research ideas that they have, where they're working in the area of NLP and CV primarily, because these two things are touching people throughout the world. Okay, when we talk about NLP is not restricted to any language. So NLP has made it possible that language is no barrier for anyone. If they want to do something by using NLP, we can make use of regional languages, multilingual stuff, voice recognition systems, and many more things. So NLP and CV are, maybe you can consider, these are the two very hot research topics that you can plan for. And if you're planning to pursue some sort of research, I think it will be a great idea, because when we talk about artificial intelligence, it is more of a research oriented area rather than simply like a software engineering stuff where you get some requirement, you develop it and you deliver it. But artificial intelligence is not like that. Okay, the more you understand the area in depth, the more you'll realize that okay, there's so much more to actually talk about and build something which focus to AI. So that is the idea.
Great, thank you for that. A couple of more quick questions I'll throw at you. Chandan had a question about how can we use computer vision in stock management system, for example, at a bookstore, which maybe Chandan works at. And then I can give you a couple of more. Well, why don't you start with that one and I'll feed you the next couple after.
Sure, Matt. So that's a very interesting question. So say, for example, you want to manage your stock. What do? You must, you need to place it on some shelf or something. So what do you do? By making use of computer vision, you can actually understand that whether that particular product, say, for example, if you consider that you have a bookstore, okay, and you're keeping your books on a shelf, okay, and by using computer vision, you can actually analyze the images of the books and understand whether those books are placed on the shelf or not, and if they are placed, what genre it belongs to, what is the name of the book, and so on and so forth. And you can actually calculate the occurrence of that particular book occurring in your shelf. So that will help you give effective way to manage stock, to manage the inventory, and obviously to manage the stock that you have. So that's the idea. So this particular concept is called as on shelf availability, or maybe share on shelf. So maybe you can look for that, and that's how you make use of computer vision over there.
Makes total sense, and I am familiar with it too. So it's a really interesting application.
Right.
A couple of more questions. Is there any scenario where general AI and super AI overlap? And another question was, how significant is the performance progress we can get from heavily tweaking models or building models from scratch rather than just using cloud providers' existing models? So that's a good one.
Okay. Okay. So maybe I'll take the first question first. I
Sure.
think that was more related to. Can you just repeat that question?
Yeah, sorry, I won't do the multiples. It gets too confusing. I can't even say them. I can't imagine how you can answer them. Is there any scenario where a general AI and super AI overlap?
Not as of now, because whatever general AI is there, which I talked about as a humanoid, they have been programmed with certain amount of restrictions and limitations, which don't go beyond human intelligence. That is the thing.
Okay. It's a limiting factor. How significant is the performance progress we can get from heavily tweaking models or building models from scratch rather than just using cloud providers' existing models?
Okay. Okay. Now, see,
so I think what they're saying is, building it themselves versus using pre-existing ones, right? Like,
yeah.
Is it better to build it yourself or tweaking from existing versus using the existing ones out there?
See, the idea is now both have their advantages and disadvantages. Okay, so both of the two things have their pros and cons. Now, if you want to, run your model fast, if you want to have a better assistance and make your system, in a shorter span of time, then maybe you can make use of the pre-trained models, perform some sort of hyperparameter tuning so that, you tweak it based on the user's data set, and accordingly you give them the results. So that will save a lot of time, because you do not have to build a model right from the scratch. You already have it built, right? Instead, what you can do, you can introduce something called as model comparison, where you can have multiple pre-trained models, okay, and you can have a configuration parameter which the user can do, and accordingly you can you can analyze that which model is performing better. So that again helps the user understand that, okay, this is the model that works the best. But building a model right from the scratch, obviously, if you are, I would say, if you're too passionate and if you want to research about how CV works behind the scenes, then definitely you can go ahead building right from the scratch as well.
Okay, great. Why don't you go back to the presentation? We'll take some of these questions a little bit later on. There's quite a few that are coming in.
Sure. Okay, sure, man. So we'll just continue forward again. Okay, and we just saw the very fundamentals of CV, where we understood what vision is all about, what a pixel is, and how images are basically interpreted by computer systems. Now, when we talk about any CV related activity, there are three major steps involved. Okay, major steps on a high level. No matter what kind of CV application you're building, these three steps will always be there. The number one step is acquiring an image. Okay, now, what do we mean by acquiring an image? Basically, this means about data ingestion, data orchestration, data acquisition, where you collect the data, you load the images in your system, you dump it there. So that's acquisition. Okay, you're acquiring some sort of data set. Obviously, the better the data you have, the better your system will be. I'm sure many of you here would have, heard about that quote, garbage in is equal to garbage out. So that's what it means. Like, that is the very first step, because you need to be very diligent that you are passing only relevant data within your system, because you don't want your system to be inaccurate, right? Because now, let me give you an example. Okay, when we talk about the healthcare industry, okay, which is more focused to medical diagnosis, clinical trials, drug discovery, and so on and so forth. Now, healthcare is a very critical domain. Okay, it's a very critical domain. You don't need, like, you can't have 98% of accuracy. You need 100% accuracy there. But how do you achieve that 100% accuracy? You achieve that with the help of data. Your data needs to be very strong. Your data needs to be very relevant. It needs to be correct. Okay, so say for example, you have 100 images in the data set, but 95 images have a certain class and just 5 images have something else. So that won't serve the purpose, right? That is something called as the data imbalance problem. That won't help you. This data is not correct at all. Your data needs to be normalized. It needs to, be balanced, and accordingly you pass it, right? So that's acquiring an image. That's acquisition of data, the very first step. Very important. The next step is processing an image. Okay, now when we say processing an image, this basically means that you want to perform some sort of data processing, you want to perform some sort of augmentation techniques. So data processing deals with like resizing of images. Say for example, you've got bunch of large images, okay, but now what are you going to do? Your system, say for example, it's not capable of handling those large set of images. What do? You process those images, you resize it, and you cut short the memory, the dimensions of that image, and you pass it to the system. It works, right? Then there's grayscaling. So if you want to just standardize all the images in a single color, you want to make it monochrome, you can do that. Then you process image. So annotating an image is one very important area, because object detection, object classification, all these deals with annotating of images. If you're using a ready-made data set, that's absolutely fine. You can annotate, you can get annotations of some very standard classes like person, head, sunglasses, okay, all these things. But say for example, if you want to annotate or detect very specific objects like your phones or your mobile devices, then you need to annotate the image. So you need to manually draw some sort of bounding boxes across the image, and you need to tell the system that, okay, this particular region is XYZ. Okay, so that's the idea. That is something called as the ROI, which is the region of interest. So when you draw that bounding box, that is the region of interest, region of interest. And accordingly, the system will then later identify or predict whether this is the same object or not. So annotation of images are very useful. It's the basic step when object detection problems are to be solved. Okay, and lastly, we have understanding of images. So you acquire the data, you process the data. Now obviously there's one last step where you actually understand the data, you make sense out of it, you build some models on top of it, and you generate inferences. So that's the idea behind the 3 steps of computer vision. Okay, so in understanding of the image, what do? You get the clarity of what that image consists of, you build a model on top of it, and you generate the prediction results, where again it gives you some sort of confidence factors. It gives you some sort of accuracy, that how well the system detected or identified whether this object is so and so or not. So these are the 3 steps: acquiring an image, processing an image, and understanding an image. Okay, now whatever computer vision systems we use, this is what we experience. Okay, you upload an image and you get some result out of it. Consider an example of Google Lens. Okay, you open Google Lens in your device, in your smartphone, and you scan it. you scan any image in the world, okay, it will give you some sort of result. It will search for very similar images on google.com. Okay, that's what you experience. Okay, so the experience is that you send the data to the system and the system provides you the results. That can either be in the form of text, it can either be in the form of images, it can be either in the form of some sort of results out of this. So that's the user experience. Okay, that is what we do and we experience. But there is something behind the scenes that is going on, and this is what it is. So there are multiple images, okay, passed to the input layer. Okay, this is the input layer, and what you see over here, these three nets. Okay, this entire area is a neural network. Okay, and what it is this is the input layer, meaning you pass in the images to the input layer. Then there are some hidden layers with some sort of weights, with some sort of biases. Okay, so you pass the images in the input layer, you pass it to the hidden layer, it processes it. Okay, and your hidden layer will give the output. So this is the output layer, and then you get the result. Now all this happens in a matter of seconds, in a matter of minutes, based on the systems that we use. Correct. So today many websites, many applications in the throughout the globe, what they do, you can upload a document. Okay, you can you upload a document online, and many times what you experience is that you get the feedback out of it. Okay, so let's say that they need some sort of document for your verification purpose. So you upload the document online and the system will just tell you that, okay, the user has been verified or the user has not been verified. Now it happens in a matter of seconds. Okay, so how is that possible? So that is possible with the help of neural network, which is a concept related to artificial neural networks, and some deep learning. So that's what it is all about. So just understand the context, that what happens behind the scenes. This is the thing that we experience. So this is the user experience, maybe you can say the front end. Okay, but what is happening in the back end? In the back end, there is a neural network, there is some sort of deep learning algorithms, like a convolution neural network, CNN. That is the most widely used neural network for image and computer vision. Okay, always remember that. So if you're starting your journey with computer vision, and if you are confused on what sort of algorithms or what sort of neural network should I work on, please work on convolutional neural network, which is nothing but CNN. Okay, so what we understand behind the scenes is that we pass the images to the input layer. This is sent to the hidden layers, and then we are able to generate the output. So this is what happens. Now let's understand that why there is a need. Okay, now there is a need because today we are not just interacting with textual information or textual data. Okay, we are interacting with multimedia data, we are interacting with a lot of more complex information, right? Now today all of us, we make use of social media. Okay, we make use of Facebook, LinkedIn, Instagram, Twitter. Now on all these major social media platforms, the majority of content, okay, that is created, curated, or whatever content is shared, that is majorly in the form of multimedia. Now Instagram is obviously, it's a media app. Okay, you can't share just text on Instagram. You can share images, you can share videos, you can share some sort of GIF animations. That's all. Okay, when you talk about Twitter is a microblogging site where you need to pass on some sort of text, but majority of users, they upload some sort of GIFs, they upload some sort of images, videos, many things. Similarly for LinkedIn and Facebook. Okay, so we are today interacting with more of multimedia data rather than textual data. Okay, and vision capabilities within a system, which actually will actually help in organizing all this sort of multimedia data, that helps us understand the patterns more efficiently. Okay, now, and also to know what is there inside an image. Okay, it is important. Now, you must have come across many such occurrences where, maybe Facebook tells you or Twitter tells you that this is not a good content to see. So it automatically blocks those kind of specific images. How is that possible? How do these organizations understand that, okay, this image should be blocked and this image should be viewed by all the users? So there's a very important algorithm working behind the scenes, which actually knows that what is there inside the image, what is the content of that image. And that's where computer vision comes into the picture. Okay. And to make sure CV capabilities are handled efficiently, there was a new terminology in the world of AI, which was deep learning. Now, I'm sure many of you must have heard about the concept of deep learning. Okay. And I'm surprised, but many people start their journey with deep learning. But I would recommend that please do not jump to deep learning directly. It's a more advanced topic. So if you want to make your career maybe in computer vision or AI or NLP, you got to start from the basics. You got to know data engineering, data science. You got to you got to then start machine learning. And once you're through with all these three, then you got to start with deep learning, neural networks, and then computer vision. So that's how your journey should be. You should never start with deep learning directly if you're new to artificial intelligence. Okay, so that's a tip y'all can make a note of. So deep learning was basically introduced to handle complex data, which machine learning was not capable of handling, right? So machine learning was capable of handling large set of tabular data, textual data. But when it came to multimedia information, when it came to pixels, videos, image frames, machine learning failed. Okay. So that is the reason, it was very important to innovate something new, and researchers and scientists worldwide, they came up with something called as deep learning. So in simple words, if someone tells you that what deep learning is and you want to summarize it, it is nothing but a combination of machine learning plus neural networks. Okay, so it automatically learns and automatically understands the patterns and accordingly provides you the results. So it's a combination of machine learning plus neural networks. And the only thing why deep learning system takes a lot of time to build is because of its high computational power. Okay, it requires a very heavy infrastructure. So it requires some graphic processing units, graphic cards, and it requires a very heavy system so that you actually accordingly build that. Okay, and and thus computer vision algorithms, they take some they take a lot of time to build and actually train the model, which takes around sometimes days, weeks, and even months. Okay, so based on the complexity of the data and based on the system or infrastructure that you have, your computer vision algorithm will take that amount of time to actually train the images. Okay, so always remember, whenever you want to build a computer vision system, you need to first acquire the data. You need to send that data to a model. Okay, I think so. One of the audience, one of the listener had asked the question that whether we build a model from scratch or we make a use of a pre-trained models with some hyperparameter tuning. So I would initially suggest to make use of pre-trained models, because those models are already developed and it gives you an edge to actually create your own computer vision system by using those models. You can tweak a lot of configuration parameters, but you all can use those models. So those models are used to train based on the custom data set that you have uploaded. And once the training is completed, you can then make use of that model to predict the results. So that's the flow. So you insert the data into the model, you train the model on that custom data set, and then you generate some sort of prediction results on the tested data set. That's the flow. So when we talk about training any computer vision algorithm, based on your system infrastructure, it might take some number of hours, days, weeks, and even months. Okay, so it's computationally very powerful, very heavy. Okay. Now, some of the real-time use cases of CV that we have are Google Lens, We all know about it. You can just, start your assistant. You can tell open Google Lens and it starts scanning things. It translates documents. It has OCR capabilities, which is optical character recognition, many other things. So basically the primary motive of Google Lens is that you just scan on any object and it tells you what that object is, and it actually helps you search for those objects on Google or some other websites. Facial recognition system in our smartphones. So our smartphones today are very smart. Okay. So and that's why they're termed as smartphones, because they have those brains and they have those capabilities to actually understand who we are and accordingly decide whether the same person is, trying to log into their mobile device or not. So facial recognition is one very good example in the world of CV. Number plate detection. So when vehicles are traveling, so number plates are detected to identify whether this particular vehicle owner is breaking any law or not. So those things are taken into consideration, again, with the use of CV and optical character recognition. Now, what is the enterprise level impact due to CV? Now, to summarize, to tell you all, computer vision is here to stay. Okay, in just one statement, if you ask me, it's nowhere going. Okay, with time, the demand for computer vision will just keep on increasing. Okay, so 5 years or 8 years ago, there was a demand of a machine learning engineer, ML engineer, AI engineer. Today, the demand is of a ML ops engineer, which is nothing but a machine learning operational engineer. So that is a combination of DevOps plus your machine learning knowledge. So that's something called as ML ops. Okay, and now slowly, steadily with time, there'll be two very prominent areas, which is computer vision and natural language processing. These areas are here to stay, 10 years, 15 years, 20 years down the line, nowhere they're going. And data generation, as I said, it's more on the multimedia side. So startups and businesses, they're focusing on vision capabilities more. The first, use case that they are focusing is security and authentication systems. Okay, which is nothing but face recognition, emotion recognition, expressions, so on and so forth. Then chatbots, where they're trying to build chatbots that also has some vision capabilities, where if you upload an image, it automatically scans the content of it. It automatically detects what kind of image you have uploaded and accordingly gives you the results. So those are area where businesses are actually investing currently. Smart cities and traffic systems, where you've got web cameras and high definition cameras attached, and there's a live feed ongoing, and that live feed is actually analyzed at a certain time interval that can be maybe every minute, every 10 minutes, so on and so forth, and accordingly it generates some sort of detection and classification results. It is used, businesses are using CV in manufacturing industries and retail industries. So I think one of the question was that how do I make use of computer vision in stock management? So that is a use case in the retail industry, where you do some sort of on-shelf availability, you do some sort of share on shelf, you understand that, okay, how many products are placed on the shelf, and accordingly you decide, okay, that these are the products in demand, these are my most selling products, so on and so forth. So you get a lot of details when you actually apply those vision capabilities and you actually analyze the shelf. Okay, so that's what the idea is. Now, what is the market growth when we talk about computer vision? As I said previously as well, two areas, CV and NLP, has a lot of potential ahead in the market. So if you are you're planning, you're still confused that, okay, I've started off with AI, but in which area do I need to make a career in? CV, NLP, any of these two areas you can think of, and it is getting evolved day by day with the rise in multimedia data. And there are organizations worldwide like Google, Microsoft, Facebook, and Amazon. They are heavily investing in vision capabilities, in building more robust models, so that the end user can actually use those models for training purpose and to create more efficient vision, computer vision systems. Okay, so Google, Microsoft, Facebook uses computer vision heavily on Facebook.com, on Instagram.com. They make use of computer vision like anything. Trust me on this. And Google also makes use of a lot of CV capabilities. They have ample amount of good research, recent researches published, which is in the area of CV. The future of computer vision, what we envision is, major systems are today, they're making use of vision capabilities. If you come across many websites and applications, they are they serve and they provide a better user experience because they understand what you're sharing, what you're doing, and what kind of data you're dealing with. And the reasons are that multimedia data, and there is a need for automated image understanding, because what happens is sometimes not good, like not ethical images are used. So it is very important to understand that what is actually present in those images. Okay. And there's a lot of work to be done with respect to image and video data. And just to summarize it, one of the most growing areas that we have right now in the world of AI, and we have multiple, industries, the practical applications like Google Lens, OCR, and more. And if you want to build a future in CV, then four things you need. Okay, you need mathematics and statistical knowledge. Okay, statistics. You should know the basics of machine learning and deep learning, please. Okay, so don't think that you know maths, you know statistics, you know programming, and you straight away build a computer vision model. Please don't do that. If you do that, it won't be scalable, it won't be sustainable. So you're going to have that mathematics and statistical knowledge, and you need to know the basics of machine learning and deep learning first. Then you're going to be better at any of the programming languages that you're good at, and you can start off building some good vision capable systems. And last but not the least, there's an optional parameter that, if it is possible, it is good. If it is not, it's absolutely fine. So you need a high configuration system, because it needs a very heavy infrastructure. As I said, it's computationally very high, it's computationally very powerful, because as I said, images and video, they deal with pixels. Okay. And pixels are nothing, they are the images are nothing but a matrix of pixels. So there's a lot of computations going behind the scenes, and that is the reason a very high configuration system is used. Okay. So that's all with regards to the deck. I would just like to give you all a small walkthrough to Colab notebook I have. Okay, maybe I'll just make you all certain packages. I'll take just a minute or two to give you all a walkthrough of what kind of packages and modules are used while building CV. Okay, so some of the few packages that you can go ahead and read about is TensorFlow, PyTorch, Keras. Okay, these are the three major packages which are used in order to build some sort of image deep learning models. Now, these are packages used for model training purpose. Now, in order to process your image, in order to, analyze your image, edit them, there are two libraries that you can take a note of, which is OpenCV and PIL, which is photo imaging library. Okay, so OpenCV is the most sought after library that is used. If you want to start off with your computer vision career, no OpenCV in and out. It is a very, very powerful Python package which helps you understand your images, analyze them in a very effective way. So that is the idea. And this is what you do. Okay, so here basically you divide the data in train and test, and accordingly here you can use some pre-trained models. So here I'm making use of a VGG16 model, okay, which has the weights as ImageNet, and this is the shape of the image. So the shape of the image is nothing but this is the size, the height and width, and these are the three colors, like the RGB components that are present. And lastly, you have some sort of functions to actually train the model, to say the model, and lastly to predict the output. Okay, So that is the idea behind building some CV systems. So you're going to take care of all these packages and libraries, which can make your life a lot more easier and better. Okay. So that's all. I would like to wrap it up over here. And if there are any more questions, I would like to take them up.
Great. Actually, great job. Thank you so much. Yeah, there's been a flurry of activity in the chat. So
Okay.
let's see. First of all, just so everyone knows, this is going to be recorded. It will be available for replay on YouTube by tomorrow. All right, so let's see. Let me scroll back a bit because I missed quite a few earlier on.
Okay.
We only have about 5 minutes. Maybe we can go a little bit over. For those of you who want to stay a little bit late, we can continue taking some of the questions. For those of you who have to drop off, we understand. Okay, so let me see. Do we need to understand digital signal processing to work with computer vision?
If you know that, it is the best thing that you can, because there are a lot of mathematical concepts that are focused to digital signal processing. And when we talk about CV, it impacts a lot, like Fourier transform and all these concepts are very useful when you deal with deep learning and computer vision. So I would say it is not mandatory to understand digital signal processing, but if you know, it is a plus. It is definitely advantageous.
Okay. All right, we'll do the speed round version of these questions. So I'll go quick, you can go quick. How can we relate deep learning, computer vision, and NLP?
Oh, that's a very interesting question. So if you want to build something very extremely powerful, I'll give you an idea. So you have a computer vision model which understands the content of the images. You implement NLP over there, which will actually help you generate some sort of content based on the image that you read, and accordingly you apply some sort of deep learning models to predict what can be the outcome. So you can combine all these three areas together and you can build something really great.
Great, thank you. How do I start to learn computer vision? Maybe I'll jump in and take that one. So Fourth Brain, we got to plug Fourth Brain a little bit. So we run, online training programs. They're live instructor led. You're in a cohort. Now, our program's a little bit different than, say, our sister company, Deep Learning AI, where those are the pre-recorded classes, very popular. Ours are slightly different. I would say, though, we do offer an MLE, a machine learning engineer program that does include computer vision. There is a requirement, though, that you have a prior experience with Python for our program. I'm not sure about the Deep Learning AI course. I would imagine there is as well, but certainly Fourth Brain, we'd love to, have you as a student, but also Deep Learning AI. I think both are great starting points. Akshay, you're welcome to promote anything else that you think might be appropriate.
I think you've covered it all. I would really love if, they get associated with Fourth Brain, because I think, I've seen just to, clear to the audience, I've seen the content, the curriculum of Fourth Brain, and I think it's, if you were to start your career maybe as a machine learning engineer, then Fourth Brain or Deep Learning.ai is the right place, because you'll get that understanding right from the basics to the advanced level.
Great. Let's see. Let me see what I missed. So we'll take a few more questions. Is only deep learning used nowadays in computer vision? What about the other algorithms like SVM or bio-inspired algorithms?
Sorry, I missed the last one. I heard till SVM after that.
SVM or BIO-inspired algorithms.
Okay, so when we talk about computer vision, majorly deep learning models are used. SVMs and other models, they're more used for your textual data, your textual information. But when it comes to images and video, deep learning models are used, as I said, because CV vision capabilities, vision systems, they require some complex processing, and deep learning is capable of doing that in a very effective way. So that is the idea behind it.
Great. Let's see. Shrikar was asking, for implementing mainstream CV applications, Which deep learning library is more popular and important to implement CV applications, TensorFlow or PyTorch?
Okay, that's an interesting question. So if you're planning to develop a product, I would say, go ahead with PyTorch, because you're planning to develop a product and deliver it. But if you're planning to, do something more from the research oriented perspective, where you want to continuously contribute, you want to develop even better, then focus on TensorFlow. So in just one line, TensorFlow is a library which focuses on more of research oriented work. A lot of researchers use that. PyTorch comparatively is quite easier to implement, to plug into your systems, and you can quickly build some sort of models. So if you want to build something really very quick and deliver it, make use of PyTorch. If you want to have some sort of strong research oriented work, make use of TensorFlow.
Someone was asking if they can have the notebook.
Oh, yeah, definitely. I'll share the presentation as well as the notebook maybe. And
we can post it down below the YouTube video tomorrow. We can do that.
Yeah.
Okay, that's very generous of you. Thank you so much. Okay, so I think maybe that'll be our last question for the day. And why don't we wrap it up? Again, this is being recorded. We should have everything back, the recording available on YouTube by tomorrow, maybe sooner, but tomorrow for sure. Again, Akshay, thank you so much for joining us. You're great. You're always great to work with. Pleasure to have you present. Hopefully we can get you back again to present at future events that we do.
Definitely.
We welcome everyone to learn more about Fourth Brain, of course, fourthbrain.ai. You can learn more. Thanks again, everyone. Have a great rest of your day, and hope to see you again in future events.
Sure. Thank you. Thank you so much, Matt. It was really wonderful, being associated with Fourth Brain, knowing you, and it was a pleasure, sharing my experiences and knowledge. Thank you so much.